With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is time constant of an given circuit is tau. If the battery is replaced by an AC source having the voltage V is equals to V naught cos of omega t, then power factor of the circuit will be. So let's look at the solution. So in this question we have given here a RL series circuit. Okay, this is R, this is L, and this is the battery. Let the EMF of the battery is A. Now it is given that in the circuit, that is, if time constant for the circuit is tau, that is equals to L divided by R. Okay, now if this DC source is replaced by an AC source having the voltage, that is V is equals to V naught cos omega t. So in that case, what will be the power factor for the circuit, that we have to find here. Okay, now if the voltage will be V is equals to V naught cos omega t, so from here I can say that the current will become is equals to I naught of 1 minus e raised to minus of RT divided by L. But as the L upon R is the time constant, so from here we get I naught 1 minus e raised to minus of t divided by tau. Okay, now let's say according to question this source is replaced by an AC source. Okay, now as we have replaced this battery source by an AC source, so in that case the impedance for the circuit can be given by first of all, let's say the vector diagram for resistor R and inductive reactance XL. Okay, so this is the vector diagram for resistor and inductive reactance XL, where XL is given by omega into L. Now if we complete this quadrilateral, okay, so in that case the resultant of these two will give me the impedance for the circuit, that is Z, which will be at an angle of phi with respect to R. Okay, from here the power factor for the circuit, that is cos phi, will become is equals to adjacent upon hypotenuse, that is R divided by Z. Now if you try to find the impedance for the circuit, so impedance for the circuit can be given as Z is equals to under root of R square plus XL square, and this is because of by using Pythagoras. Okay, so if you put the value of Z here, we get R by under root of R square plus XL square. Now XL is equals to omega L, so we directly put here omega L, that bracket square. Okay, now if we take R common from denominator to out of the square root, so it will become out like R. So what will be remain here? Here it will be 1 plus omega L divided by R, that bracket square. Now here this R will be get cancelled. We get 1 divided by under root of 1 plus. Now L upon R is the time constant, which is given by tau. So here we can replace L upon R by tau, that bracket square. Okay, so the required power factor for the given circuit will be 1 upon 1 plus omega tau, that bracket square. Okay, so according to this, if we check the given options, so option second will become correct answer for this question. So this is the required solution. I hope you understand. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.